Okay, so here's the probability recap. So let's go ahead and talk about the formulas that we've been learning so far, and also the keywords that you should kind of look out for. So first I'm going to write formulas right here, and then I'm going to write keywords. Okay, so the first formula that we have spoken about is the complements. So probability of a complement is equal to 1 minus the probability of A. And remember that this is basically the probability of not A. So if you think of a complement, that just says not A. So the probability of not A occurring is equal to 1 minus the probability of A. So some of the keywords that you want to see is not. Okay, so that's just very basic. Usually this one you don't really need a formula. You just need to do it. If you read it, you can kind of just do it in your head also. Okay, so that's the complement formula. The next one that we've talked about was the addition rule. And we said that the addition rule was the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. Okay? And here the keywords that you kind of want to look out for is or. Okay? And you can always think that or just means addition. Okay? So whenever you see or, what I like to do is look at the last two or look at the last sentence and look for the word or. And then what A and B would be, it would be whatever the first or the two things right outside of the or would be. So if I say the probability of getting a female or a cat, then female would be A, B would be cat. Okay, so usually the last sentence would kind of tell you what the two events should be. So look out for the word or. Okay, so now the next one that we've talked about um, was the multiplication rule. So the probability of A and B. Okay, and this is equal to the probability of A times the probability of B given A. Okay, so remember that this is not division. This just means probability of B given A. Okay, and really what you want to look for in these types of problems is the words and, obviously, in a row. Okay, so these kind of will give you a hint that this is going to be the probability of A and B. Also, keep track of this particular multiplication rule because notice how there's an and right here. This thing is not multiplication rule. This probability of A and B when you're dealing with an or problem is probably going to be given to you. However, in this one, what this A and B represent is that A is first, followed by B. So that means two things are occurring not simultaneously, but one thing happens first, followed by another thing that's happening. Okay, so that's why I wrote in a row right here. Probability of A is basically the first thing that happens times the probability of B given A, which means that the probability of B occurring given that A already occurred. Okay, so that's the multiplication rule. And usually you will see these problems with like marble questions. Okay, if you see some sort of marble questions, when you have like two spinners, that's when you really want to multiply these things out. Um, and also later on, what we'll talk about is associated events. We'll talk about those two in a little bit. So this is kind of when you want to be able to multiply a couple problems. When you have marble problems or two spinners. Okay, obviously there's more to it, but for this class, this is where you really want to be able to multiply them. Okay, the last one, this one's optional. I did write down the formula for it last time, but the probability of B given A is equal to the probability of A and B divided by the probability of A. So this is what we call conditional probability. And what you really want to look out for is the word if, given that, or maybe of. So basically what you're doing is you're restricting um, um, the probability to just whatever A should be. So basically your denominator, I'm going to write it right here, denominator is restricted to A. Okay, so you're just restricting the denominator. So if I said if there are 20 males, then your denominator will be out of 20. Okay, so usually you don't really need this formula if you don't really want to use it. You can really just do it with a contingency table, but I'll write it down here just in case you really want to figure or have it in your notes. But these are basically the main key um, four formulas that we've been basically using. And then we've been talking about other different things. So, for example, we've talked about being a disjoint event, and we've also talked about an independent event. So I'm just going to write here disjoint, and we've also talked about independent. Okay, so there's a difference between both of them. This one with disjoint means is that they can't happen at the same time, so cannot occur at the same time. Okay, so two things cannot occur at the same time. So, for example, you can't have heads and tails in one particular toss. So, what that means is that disjoint events exist only in one trial. Okay, so if I only do something one time, so I flip a coin just once. Okay, that's where disjoint events kind of exist. Independent events, what they mean is that one event does not affect the other. Okay, so the fact that one thing happened isn't going to affect the other one. And this happens when you have two trials. So two things are happening um, at two different places. So, for example, something happens first, then another thing happens. So, getting heads and tails, and so if I get heads in the first toss, that's not going to affect my second toss. Okay, of getting heads is not more likely to get heads or tails if I know that I got heads the first time. So, what you can further say is that the probability of A and B occurring for disjoint events is zero. Okay, because since they cannot occur at the same time, that means that the probability of both of them occurring is equal to zero. For independence, I'm not going to make you prove this, but just for your FYI, and I'll put it in yellow just so that you can say that it's optional. Probability of A and B is equal to the probability of A times the probability of B. This you don't really need to know, but just in case you really are interested, this is how you can calculate independence. If the left-hand side is equal to the right-hand side, then they are independent. Okay, but I do want you to know the differences between these two because these two are not the same. Disjoint and independence are completely different from each other. Okay, so I'm not going to do any examples. We did a couple of examples in class, but these are basically some of the formulas that we've been talking about with a couple of the key words. And then the differences between disjoint and independent. So in the next video, I'm going to do a couple worksheet problems that we've done in class and finish them off.